Okay, so now we're going to work with melting blocks. Melting blocks are really cool, and I love doing these with my students and then just kind of leaving them hanging at the end of class. This is a good anchoring phenomenon, so it gives them something to look at and think about, and then kind of do the teaching and exploring to understand what actually happened after they've viewed it. So melting blocks are just these two squares. You could probably teach this remotely, though you would more than likely need to help prompt them. I have them make a T-chart to compare the two. That could be what they look like, what they feel like, sounds, you know how they will beat on them or do all kinds of things that you haven't imagined. But you need to have a lot of the properties of each one. I'll just tell you that they do feel different. This one has a little bit more of a rough texture. This one's a little smoother, but they are both black. They're both solid. Obviously, things like that would be given as their observations. Remotely, they would not be able to tell that this one feels cooler to the touch. This one's cooler to the touch, and this one is warmer to the touch. But that, if they were doing it in person, that is definitely going to lead their thinking as they come up with an explanation. So after they have gone through and given you all types of properties to describe them, then I give them these two rings. I don't give them ahead of time because it's totally irrelevant to the squares, and they get focused on the rings otherwise. The rings are only there to help prevent a mess in the future. So they just go on top of the melting blocks like that, and then you're going to give them a piece of ice. It is important that they wait and use both pieces of ice at the exact same time. That way they can really view and appreciate what they're going to see. So it doesn't really matter how big the pieces of ice are, but they should be fairly similar in size. And you might even have them predict what they think is going to happen when they put the ice on there. But when you put the two pieces of ice and then you watch them, and hopefully you can see, I'm going to tip it just a tiny bit. This one is already melting quite a bit and actually dripping off, which is why I have this on a tray, which is another thing just for preventing mess on the table and quicker cleanup. This one is melting, but just barely. And that is fascinating for students, and they can't figure out why this one almost disappears in front of their eyes, and this one will take close to 5 minutes before that same size ice cube will disappear. This one actually started out as a larger ice cube, and it is mostly gone by now. So then I ask them to try to come up with a reason for that. And of course, they're very keen to point out that this was colder to start with and this was warmer. And so this goes against what they were thinking. So at this point, I have them model their thoughts. Modeling can be pictures, can be words, doesn't matter. I give them a paper to work as a table group. They aren't going to come up with an answer very likely on their own. So I give the table a piece of paper like this. It gets folded. Let me just show you how this will get folded. It gets folded into fourths. And then after it's folded in fourths, you fold down one corner. When you open that back up, then that gives a table map. And so your four groups, or the four people in your group, each person has a little section where they put their ideas with no judgment, trying to explain what's happening with those ice cubes. After you've given a few minutes to figure out what they want to say, and everyone has to contribute, then they can do a think, pair, share, or they can just talk as a table group, looking at all the different ideas that each person has come up with. When they then have sort of come to the consensus about what they think an explanation for this is, then that is what's written in this center section. So individual answers are written around the edge. They're collaborating and putting a shared answer in the center, which gives them a little bit more confidence when they share with the class then, because I do want them to try to explain in the best understanding they have what's going on with this. Usually that's about the end of class, and they are all clamoring for answers. Why does this work? Tell us. And, it's just a lot of fun to say, I don't know. We'll just have to see if we can learn and find out. Yes, this one is completely melted. This one is still quite a bit of the ice cube is left. So that is very puzzling to them. And I take great delight in not telling them an answer on that day. So when they come back the next day, then we can continue with this. One thing that I do sometimes is we repeat the activity. You can put a thermometer, like a digital thermometer with the probe underneath each of these so that they recognize that they start out at room temperature. They may feel differently to the touch, but they are actually the same temperature. Room temperature means they are the same. We perceive them to be different because one of them is a better conductor. And so it's pulling the heat out of our hand and more effectively. And so the metal, which this happens to be metal, and I don't tell them anything about them, so they don't know what it's made out of. I just say, I don't know, put down your best answer. So this one is a metal, and this is a plastic. And the metal is, of course, is a better conductor. So it conducts the heat and draws heat from the room and melts this very quickly. That still is a difficult concept for some of them to get. So another way that you can show that that probably is a little easier for them to grasp and they will understand it a little bit better for those that may need it, is that you can also take a plastic spoon and a metal spoon and basically do the same thing and put the ice cubes in the two spoons, and then if they hold the spoons, they can see the heat. They will grasp the idea, hopefully, a little bit better, that the heat from their hand is warming the spoon, which then warms and melts the ice cube. And the plastic one does not transfer the heat very well, and so it takes much longer for it to melt. So making sure that they recognize that heat energy is what moves. There is no cold energy. So this is not gaining cold, it's losing heat. And that's a big sort of change, terminology that I have to make sure that we do. But just holding the two different spoons generally helps them grasp it if they don't get it from this. But they always have fun, and then you can hear them talking about it in the hall. You're going to do something fun in science today, because this is just such a mystery for them.